Let's jump right in. Welcome to this explainer of the Botanical Detective. Today, we're going to take you from a frustrated gardener to a full-blown botanical detective. We'll be walking through the exact systematic method for solving the ultimate backyard mystery. Why are my plants dying?
Look, we have all been there. You walk outside with your morning coffee and bam, your absolute favorite plant is suddenly wilting. And you immediately think, okay, who or what is killing it? Our first instinct is usually to just panic, right? Or maybe take a wild guess and grab some random chemical spray from the garage, hoping for a miracle. But listen, jumping to conclusions, that is literally the quickest way to make the problem so much worse. Instead, we need a highly systematic, step-by-step approach to confidently figure out exactly what's going wrong.
Because figuring out what's ailing your plant, it's not a guessing game. It's actually an inherently forensic process. Think of your garden like a crime scene. You've got to carefully collect clues, piece together a cohesive narrative of distress, observe the environment, look for hard physical evidence, and systematically eliminate suspects before you can definitively name your culprit. All right, so let's get into the absolute best tool in your detective kit. Host specificity. This concept is going to be our main focus today because it's the fastest way to cross names right off your suspect list. Host specificity basically means that most living plant pathogens and pests are incredibly picky eaters. They are biologically locked into attacking only one specific plant species, or maybe one specific plant family. They don't just eat everything in sight. So let's look at how this plays out in the real world. Say a mysterious problem is hitting your tomatoes, your marigolds, and the giant oak tree in the back, all at the exact same time. Well, because of host specificity, you're almost certainly looking at a broad, non-living environmental issue, like a sudden frost or drought, because those completely unrelated plants do not share the same pathogens. But if the damage is strictly zeroing in on the tomatoes while everything else looks fantastic, boom, you are probably dealing with a living, highly host-specific bug or disease that only goes after the nightshade family. Okay, let's talk motive. Check out the disease triangle. An infectious outbreak in your garden doesn't just spontaneously happen. It only occurs when three very specific conditions align perfectly. First, you need the pathogen itself. Second, you need a favorable environment, like super high humidity or soggy soil. And third, tying right back to our main theme, you need a susceptible host. If that specific plant isn't a biological match for that specific pathogen, the disease simply can't take root. Now here is the really good news. If you remove just one single side of this triangle, the disease stops in its tracks. You can literally break the triangle. You could swap in a disease-resistant plant, which knocks out the susceptible host leg. Or you could just space your plants out a bit more for better airflow, totally removing the favorable environment leg. It's all about putting the power right back in your hands. So let's keep following the clues by splitting our suspects into two main lineups, biotic and abiotic. Biotic factors are your living suspects, the fungi, the bacteria, viruses, and insects. Abiotic factors, on the other hand, are non-living stressors. We're talking extreme drought, maybe an accidental chemical burn from a weed killer, compacted soil, or poor drainage. And here's a surprising fact for you. Abiotic issues are actually the most frequent cause of plant problems, by far. Just look at this scene. When you see uniform dieback where a whole swath of trees or plants is suddenly struck down at once, you're almost certainly witnessing an abiotic event. Non-living problems usually hit suddenly. They don't slowly spread from leaf to leaf over time, and they leave a very uniform, consistent pattern of damage across an entire area. So if a whole row of your shrubs turns brown overnight after a harsh freeze, that's an abiotic stressor at work. Zooming in on that idea of uniformity, check out these needles. Notice how they're all damaged at the exact same length simultaneously? It's literally a straight, uniform line of dead brown tissue. That right there points directly to an environmental stressor, like maybe a chemical spray drifted over, rather than a living, spreading infection. A living disease would look way more random and scattered. So how do we put all this together? Let's turn to a super reliable 4-step investigative framework. Step 1, as we've hammered home, is always identify the host. Knowing your plant's exact identity immediately eliminates like 90% of your biological suspects thanks to host specificity. Then, step 2, describe the problem with real anatomical precision. Step 3, look at the distribution. Is it scattered or uniform? And finally, step 4, check the timeline. Did this happen overnight, or has it been slowly progressing for weeks? Now, when you're actively out there in the dirt gathering evidence, you absolutely must know the difference between symptoms and signs. Symptoms are just the plant's physiological reaction to being stressed, things like wilting, yellowing leaves, or stunted growth. Signs, however, are the actual physical presence of the culprit itself. You're looking for the fuzzy gray mold, the slimy bacterial ooze, or the literal insect frass, yeah, bug poop, left behind on the leaf. Contrasting that physical evidence is absolutely key. For example, fungal infections typically leave dry, defined spots. A lot of times they have concentric rings, kind of like a target. But bacterial pathogens, they usually produce a really distinct, wet, sometimes nasty-smelling, slimy ooze. Knowing this visual difference is huge because the way you treat a fungus is completely different from how you handle bacteria. And then we have viruses. These guys are the systemic saboteurs of the garden, and they are super tricky. Why? Because they don't leave those obvious physical signs on the outside. You won't find any fuzzy spores or slimy ooze here. Instead, they hijack the plant from the inside out. To spot a virus, you want to look for weird mosaic color patterns, a mottling of light and dark green, or severely distorted, crinkled growth, which usually shows up right at the top in the newest leaves. Now, if insects are your prime suspects, you really have to get in close and look at their specific feeding patterns. You can't just guess. You need hard evidence. This means comparing the visible top-down chewing damage of a caterpillar, like a big green hornworm, to the sudden, mysterious wilting caused by a grub tearing up the roots below ground. They both wreck the plant, but they do it from completely opposite ends. Here is something that trips a lot of people up. Before you ever assume a botanical crime has been committed, you have to know what the plant's normal appearance actually is. I know, it sounds obvious, right? But you'd be surprised how many gardeners panic over totally natural cycles. Like, evergreens naturally drop their older, inner needles every single fall. Or maybe you bought a plant that naturally has yellow-green, variegated leaves. If you don't know the baseline, you're going to end up trying to cure a plant that is already perfectly healthy. Which brings us right to the golden rule of the botanical detective. Always, always rule out abiotic causes first. Seriously, before you go out and spend money on expensive fungicides or bug sprays, check the environment. Is your soil heavy clay that's suffocating the roots? Did weed killer drift over from your neighbor's yard? Or did you just overwater the poor thing? These non-living issues are incredibly common, they're usually an easy fix, and best of all, they don't require pouring harsh chemicals into your garden. So there you have it. Now that you're armed with a solid understanding of host specificity and the whole forensic diagnostic process, you never have to just guess in the dark again. You know to look for uniform versus scattered damage, you know to hunt for actual signs instead of just reacting to symptoms, and you know exactly how to break that disease triangle. The only question left is, armed with all these new tools, how will you systematically investigate your next garden mystery?